Hey guys, this is Miss Went, and I want to show you a couple videos regarding heating curves. So what this setup is here, I'm going to pause it real quick. This is a YouTube video of a lab that we have done in various forms in class. So inside the speaker, there's a big block of ice, and you can see at the bottom there's some water where it has melted, but this black stick here is actually a temperature probe, a thermometer, and it's got a wire here and it's connected to the computer. So this is a graph of the temperature, and the graph is in Celsius. So you can see at the very beginning of the video here that the water was below zero. It was very cold. Okay. And so it was super cooled, probably using liquid nitrogen. And just being out in the room temperature is much warmer, so it started warming up, and you can see the temperature went up and up and up and up and up. And now it's at the 0 mark, okay? And 0 Celsius happens to be the freezing point of water, which is also the melting point, okay? So if you watch the picture there, you can see it's melting away, and it's all a liquid. Well, I'm going to back this guy up again, okay? So we know it's going to turn into a liquid. Let's back it up and watch the graph part again. Okay, so it starts off very cold, heats up, heats up, heats up. It's still mostly ice. A little bit around the edges are melting. But right here, right before it gets to 0, you notice the thermometer is still fully encased in the ice. So these little edges out here, the thermometer's not really reading. So we're just going to say that everything by the thermometer there is a solid. When the temperature gets to the melting point, which is also the same temperature as the freezing point for water that's 0, watch what happens to the graph as the ice melts. It's still absorbing heat energy from the room, but the temperature is not going up, okay? Now we got a little bump there where the ice fell off, and now we can see here everything is a liquid, and that liquid is heating up very rapidly. Now this video is sped up, and also this metal box that the beaker is sitting on, that's a hot plate. So that's like a little heater to help speed this along as well. Okay, but the point is, when that water was changing, the graph here remains flat. It's still getting heat energy, but all the energy is being used for the change. It's being used to break apart those solid atoms that were really tightly packed together and had a really strong attraction. We've got to break that attraction apart, and that takes a lot of energy here. So all the energy is used to break the attraction, not to actually make the temperature warmer. Once the attraction is all broken, the ice has fallen off, it's all liquid, then the temperature will continue to rise as we get more heat energy. Okay, so let's keep going until this thing boils. What do you think is going to happen? So the boiling temperature of water is 100. Now I can see I do have some evaporation happening. That happens before the boiling point. But now I see little bubbles, and once again, my temperature graph remains flat as we do a change. And we are going to change this liquid water and change it into a gas state. And you can see that the volume of the beaker is going down during all that. Okay, this is a totally all right. Now, let me show you kind of another version of here. Do this guy. Nope, that's not what we want. Hold on, Miss Went's being silly. Go into our chemistry video list here. All the way down. That's the version I want. All right, so here we have heating curve of water. Now, this machine here, let me explain this a little bit. This has a heater side. So we have the heater going, but we also have a spinning side or a stirring side. In the bottom of the beaker, it's hard to see while it's paused, but there's a white magnet. And inside this metal plate, there's a spinning piece that will make this magnet in here spin. So the liquid inside is constantly being turned. which is good for a lot of chemical reactions and for mixing different chemicals and stuff. So this hot plate has a stirring feature, which a lot of hot plates do. And this is ice water. So it's a mixture of solid ice and liquid water. And you can see that the temperature is at 0. Okay. So once again, let's watch this, guy. So we have our temperature probe in here hooked up to a computer. And you can see that all the little chunks of ice are starting to melt. But we're adding heat from the hot plate, but the temperature is still remaining at a 0. It's because the added heat is used to break that attraction parts apart, and we're not really moving faster yet. So the particles are still going the same speed, they're just not as close together. So the temperature is not rising. But as soon as you see all the ice gone, now you got a better shot of that magnet at the bottom, you're going to see the temperature start climbing up rapidly once the ice is melted. Okay, so most of it's gone here. Our temperature's creeped up to 2. There's still a few little hanging on pieces of ice in there. But once all the ice is gone, you're going to see our temperature start going up more. And you can see on the graph there, it's going up. So because the particles have gotten some heat energy, they're bouncing around faster. And the temperature is a measure of how much bouncing around they're doing. Okay. So you can see that the video kind of jumped ahead a little bit. And we're going to jump ahead a little more. 50, 60, 80, da-da-da. Let's see. So the rate of temperature increase has started to slow down. You can see that slope of the line's kind of evening out. So it's not necessarily a straight line, although some of your worksheets are going to look like that. Okay. So the temperature of the water is warmer than the air outside. So some of the heat we're putting in here is actually leaving and going into the air. Heat energy always flows from high heat to cold heat. And we also have at the top of the beaker, you can see some evaporation happening too, and that's going to take some of our heat energy away. But eventually we're going to reach that boiling point, and we're going to start seeing more bubbles in the water. So I can see some little bubbles. The spinning magnet makes it a little more tough to see that. But you can see once we get to that boiling point, once again, the graph does level off into a straight line. So she turned the spinner off on the thing. Now it's a lot easier to see the bubbles going there. So as this keeps boiling, we're going to get a smaller and smaller volume. So I'm going to skip this ahead a little bit here. So our phase change at the top evens back out again and stays pretty even as our water boils. Now, it doesn't say exactly 100 on that beaker, but what it could be from is if somebody has too much like rust in the water or chlorine or things like that, that's going to change the temperature a little bit. Now, this does work the same way if you're freezing something as well. So you've got a worksheet to kind of analyze, and I'm going to have you go ahead and try that and shoot me a copy back when you're done. And tomorrow we'll kind of take a look at your worksheets and see what questions you had and if there's anything we're not real clear about. Okay, have a great day, guys.